Hello friends, welcome to our YouTube channel. Today we will be learning about plate tectonic. Let's start. Did you know that in early 19,000s, a German physicist and meteorologist man named Alfred Wegener has noticed that the shape of the continents are like for each other? He has a theory that all of the continents that we see used to be in supercontinents that he called Pangaea, that after millions of years slowly drift away. We have three compositional layers or three main parts of the earth: the crust, mantle, and core. The crust is made out of lighter silicates, the mantle is made of iron magnesium silicates, and core is made out of iron. We also have the mechanical layer, lithosphere, asthenosphere, mesospheric mantle, outer core, and inner core. A lithosphere is the rigid outermost rocky shell of a terrestrial planet or natural satellite. On Earth, it is composed of the crust and the portion of the upper mantle that behaves elastically on time scales of up to thousands of years or more. The asthenosphere is the mechanically weak and ductile region of the upper mantle of Earth. It lies below the lithosphere, at a depth between 80 and 200 kilometers below the surface, and extends as deep as 700 kilometers. However, the lower boundary of the asthenosphere is not well defined. The lower mantle, historically also known as the mesosphere, represents approximately 56% of Earth's total volume and is the region from 660 to 2,900 kilometers below the Earth's surface. Between the transition zone and the outer core, Earth's outer core is a fluid layer about 2,260 kilometers thick, composed of mostly iron and nickel that lies above Earth's solid inner core and below its mantle. Earth's inner core is the innermost geologic layer of planet Earth. It is primarily a solid ball with a radius of about 1,220 kilometers, which is about 20% of Earth's radius or 70% of the Moon's radius. There are no samples of Earth's core accessible for direct measurement, as there are for Earth's mantle. Now, do you see this picture? That's right. This shows our continent. But did you know what piece of crust it is called? That's right. That is the plate tectonic. Plate tectonic is the piece of Earth crust. Boundaries of tectonic plates is called plate boundary. Since all of the continents of the world is on top of the tectonic plate, and since the earthquakes is the result of the tectonic plate moving, that's why we have the continental drift. Now, did you know that we have something called Pacific Ring of Fire? If not, then I will tell you. This Pacific Ring of Fire is located in the Pacific Ocean. Many volcanic eruptions and earthquakes occurs to the country that surround it. For example, our country, the Philippines. We have so many earthquakes and volcanic eruption occurring because we are in the Pacific Ring of Fire. Now that we have learned about plate tectonics, let's go learn about plate boundary. There are three types of plate boundary: the divergent, convergent, and transform. But before that, you should know that we have two types of crust: the continental crust and the oceanic crust. The continental crust is made of granite, so it's low density, while oceanic crust is made of basalt. That's why it's high density. Let's start with divergent. The divergent boundary is the one that separate or go the other way. For example, is the Libyan African plate and the Somalian African plate. Because of divergent, it is slowly drift away from each other. Divergent is also the one who creates new crust. The reason is because when the continental crust separate, a magma will arise from the asthenosphere, and while it separates, the magma that came out will cool and solidify because of the air and possibly a water. This divergent boundary result in a rift or a ridge valley, like this picture. This is what happened in the continental to continental divergent boundary. Now for the oceanic to oceanic boundary. In the oceanic to oceanic boundary, we have something called seafloor spreading or mid-ocean ridge. Like the continental to continental divergent boundary, it also creates new crust when the magma arises while the oceanic crust diverge or separate. Since it's in the ocean, it cool and solidify easily. So the old oceanic crust is denser while the new oceanic crust is less dense. Now let's go to the convergent boundary. We have three convergent boundary, and that is the continental to continental, oceanic to oceanic, and continental to oceanic. We will start with continental to continental convergent boundary. In this convergent boundary, we have something called mountain belt. When the continental to continental convergent happen, crusts pile up making some mountains. Mountain belts are a group of mountain ranges with similarities in structure, form, and alignment, all having been caused by the same tectonic process or convergent boundary. Example of mountain belt is this picture. Next is continental to oceanic convergent. We also have something called continental volcanic arc. This happened when the continental to oceanic collide with each other. For this to happen, we have something that we call subduction. Subduction only happened to convergent boundary. When a convergent oceanic crust collide, the oceanic crust will go down to the asthenosphere because the oceanic crust has a high density since it's made out of basalt. While the oceanic crust go down, the place where the oceanic crust go down is what we call trenches. The continental crust will pile up since it have a low density. The magma that piles up at the crust going down to the asthenosphere will rise up to the crust above it. Next is oceanic to oceanic convergent. Like the continental to oceanic convergent, these also have the subduction, volcanic island arc, and trenches. But instead of having volcanoes on islands, we will have volcanoes under the sea. Just like the continental to oceanic, one oceanic crust will go to the asthenosphere. We will have volcanoes under the sea. Just like the continental to oceanic, one oceanic crust will go to the asthenosphere while the other will pile up. The magma that was stuck in the oceanic crust going down will pile up and will rise to the oceanic crust that are piling up. And once the magma rise, it will mostly erupt. That is the convergent boundary. Now let's move on to the last plate boundary, and that is the transform. In this boundary, there will be no ridge or rift, seafloor spreading, trenches, subduction, and volcanic island arc. But without having any of those, this plate boundary is the most dangerous since it's more of earthquake. Like convergent boundary, it has continental to continental, oceanic to oceanic, and continental to oceanic boundary. The perfect example of this is the San Andreas Fault. You can see that in the middle of it is a very deep hole. It's when the two crusts grind with each other. They will create a big and dangerous earthquake. Remember that in the transform boundary, there is no magma, no volcanoes, and no rift valley, but have lots of earthquake. Now, this is the end of this video. I hope that you learned something from this. Thank you for watching. like, subscribe, share, and comment. Bye!